Okay, so today what we're going to do is we're going to continue our look at building the rules for using algebra, right? We've talked about what terms are. We've talked about what constants are. We've talked about combining like terms, right? We looked at some fractions. We also looked at how multiplication and division don't get written the same way anymore, right? And so we're going to continue that on that same theme by talking a little bit about brackets. And you've used brackets in your order of operations since you started doing order of operations, right? But when you start introducing the ideas of algebra, then it's going to change things, and we need to be a lot more focused and organized in our work. So what we're going to do is we're going to talk a little bit about brackets. The first thing I want to do is remind you of a word that we've used before that often gets so wrapped up in one space that you think of it as one thing, but it really means something else. And that's the word coefficient. When we're talking about a term, the coefficient of a term is always the same part, right? It's always the number, right? But in reality, the word coefficient doesn't mean the number. The word coefficient really means a multiplier. And that makes perfect sense if you think about what 4x really means. It literally means 4 times x, right? Because they're stuck together with if you don't have a symbol, that means multiplication. So the 4 is really a multiplier. It tells you how many times. Remember all those pattern sets that you did before? You did the subtraction to find out what multiplier you were using, and then you did like 2n plus 7 or 2n minus 1, those kind of things. So you were finding the multiplier. And so coefficient doesn't mean number. Coefficient means what? Multiplier. Okay? So that's first. Now, many times a coefficient or a multiplier is indeed a number, right? Like 4 times x. 4 is the coefficient, which is the multiplier of the x. So it means 4 multiplied times the x. Make sense? Okay, so be careful. Don't think of coefficient as a number only. It just means any multiplier. We good? All right. Now, let's talk a little bit about brackets. You've heard of the order of operations before, right? And brackets always come when? First. But what you may not know is that brackets have their own order of operations. In other words, there are certain steps for getting rid of a bracket that have to be carried out in order, or else it will not get you the correct answer, right? And that's what the order of operations does. It tells you how you must do the problem in order to get the right answer, right? So brackets have their own order of operations. The first thing, or first place you look for in a bracket, is you look inside the bracket. If there's anything inside that you can do, you will do it. Any addition, subtraction, multiplication, division, whatever. But anything inside has to be done when? First. Excellent. Then the second thing you'll do is you'll look for an exponent or an index or a power, whatever word you prefer. It makes no difference to me. And when you see one, and I'll write an example down in just a moment so you can see what that looks like. Now, we're not going to have any exponents on our brackets in this class, right? But as you move forward in algebra, you'll see them a lot, okay? And then the third and final thing is the coefficient. And again, coefficient doesn't just mean a number. Coefficient means a what?
Multiplier.
A multiplier. Okay? So, those are the 3 steps. So what I want to do is I want to write down an example of a bracket, and I want you to identify each part. The inside, the exponent, and the coefficient. Okay? So let's look at it. Say we have 3x, open the bracket, And you have x minus 2, close the bracket, and we'll just make it to the second power. This is an example of a bracket that has all three parts. Now, we're not going to even think about working it out right now. All I'm interested in right now is I want you to tell me where the pieces are. So when I say the inside of the bracket, where do you think that means?
The x minus 2.
Exactly. This part is the inside. Right? Makes perfect sense, right? It's anything that's enclosed in the bracket. Okay? Good. Now, what if I wanted to know the exponent on this bracket? Where's the exponent? Okay?
The exponent is 3.
Well, be careful. The exponent.
That's the...
So the exponent is the little number that's floating off on the upper right-hand side, right? So in this case, the exponent is a what?
2.
Is the 2. Good. Okay? Good deal. And then finally, the last thing we're looking for is called the what? Coefficient, which simply means a multiplier. And what is the coefficient of this one?
3.
Well, be careful.
3x.
Yeah, it's the entire multiplier, 3x. That is the coefficient. And the reason I know it's a coefficient is because anytime you have some number right up against, or something right up against a bracket, what operation does that always indicate? Multiplication. Okay? So it doesn't matter how big or how small it is. If it's right up against the bracket, then it's a multiplier. Yes?
An exponent is what is being carried out, right?
Well, an exponent is always just going to be the number that's here on this,
On the top?
right here in the upper right-hand side.
Okay.
Okay? Just like if you had x squared, that square is the exponent, right?
So there isn't always...
And there isn't always an exponent.
Okay.
But if there is no exponent, what do you assume that exponent to be?
1.
A 1. So there is always, but we don't write it if it's a 1 because it doesn't change anything, doesn't do anything, right? Now, so let's do another one. All I want you to do is I want you to label or tell me what the three parts are. So let's say I have negative 2x, bracket, y minus 3, close the bracket, here. Okay? So, the first part of every bracket we look for is where? Inside. And what is it, the inside of this bracket? Just the y minus 3. Excellent. So y minus 3 is the inside, right? Then the second part I do is the exponent. And what is the exponent in this case?
4.
The 4 is the exponent in this case. Excellent. And finally, the last thing is called the coefficient, which is the multiplier. Be careful because the coefficient is every part of the thing on the outside. So what is the coefficient here?
Minus 2x.
Minus 2x. Excellent. Good. Okay? Everybody okay with that? Now, again, remember, because it's right up against it, it's the coefficient. Look at this one. Okay? So, looking at the bracket, first you look inside. What's inside this bracket?
X minus 2.
X minus 2. So that's inside the bracket. So that's part of the bracket. Then you'd look for an exponent. But do you see one?
No.
No, which indicates that it's a 1, but who cares because an exponent of 1 doesn't do anything, does it?
No.
And then the last thing you look for is the coefficient, which is the multiplier. And so,
3x
is the
plus.
coefficient 3x here?
3x plus. It's x.
This 3x has nothing to do with the bracket at all. Remember that A multiplier, the only way it can be multiplier is if it's right against the bracket. Is that 3x against touching the bracket?
No.
No, then it's not the multiplier. So the multiplier is our imaginary 1 that we get if we don't have something in front. So it's just a positive 1. Okay? So be careful. If you don't have a multiplier, if it's not exactly touching it, then it's not the multiplier, right? Remember that we said that every time you see a plus or minus, you're starting something new, right? It's a new term. So that means this plus is the beginning of that bracket term. But the 3x is separated from it because of the plus. Okay? So let me write down another, and all I want you to do is I want you to tell me where the bracket actually begins. Okay? Where does this bracket actually start?
At the end?
Okay. Well, be a little more specific, though.
Minus.
At the minus 3y. That's the bracket. So it's the bracket term. It's not the 3x or not the positive 2 because you see a sign between them. So that sign is the beginning of that last term. Okay? So be very careful. Here is the bracket term. Okay? So what if I have this? Okay? There's a bracket, yeah? So where does that bracket actually begin, the bracket term? Which thing starts it? Yes?
At the 2.
At the 2. So the 2x part is the coefficient of it. Okay? Because it's all put together, there's no pluses and minuses. What if I had 2x plus a bracket? Is that 2x part of the bracket? No. If it's separated by a plus or a minus, then it's not part of it. Yes?
Could the coefficient be on the other side of the...
It could be, but it'd be very unusual. You might see that in when it comes from like a physics problem or something like that, something where you're solving a word problem kind of thing. But it'd be very rare, and it's not very good form. The first thing you would do would be rearrange it. Okay? So does everybody see the parts of it? The parts of the bracket, yeah?
Yes.
Okay. Then let's move on and talk about how to eliminate them. So the first thing we do is we look inside the bracket, right? So that just means do any math that you see inside. Are there any like terms? Is there any addition or subtraction? Is there an exponent inside? Whatever, right? So just like anything else. And that's going to be pretty rare for you right now, but we'll do some examples where they do happen. The second thing is the exponent. You're not going to have any exponents on the brackets right now. But remember, it's easier to learn something right the first time than try to fix it later. Okay? So, always ask yourself the question. And the last thing is something called the what? The coefficient, which is simply another word for a multiplier. Well, if it's a multiplier, that means you're simply going to multiply that coefficient times everything inside the bracket. Okay? So, multiply that coefficient times every term inside the bracket.
So this is the order of operation for brackets, right?
Mm-hmm. Inside the bracket. Sorry, brackets, bracket, singular. Okay. So, I'm going to write it out in what's called general form. That means I'm going to use all letters, no numbers. So that means there's not going to be any multiplication to do. I just want to show you what I mean by that. And again, we're just talking about that last step. because we would have already done everything inside, but inside I have b plus c. Can you add a b and a c together? No, because they're not, what are they called? Like terms. I can add c's and c's, right?
Yeah.
And b's and b's, but I can't add b's and c's. Good. All right? Good. Now, there's no exponent, right? But there is a coefficient. What is the coefficient of this bracket?
A.
The a, exactly.
I thought it has to be a number.
Nope. Remember, coefficients can be any multiplier. That's where I want you not to think of a as coefficient as just being a number. It means any multiplier. Now, where is a coefficient always a number? When it's the coefficient of a term, right? But if it's a coefficient of a bracket, it doesn't have to be. If it's a coefficient of a term, it's always the number part, right? But this is not just a simple algebraic term. This is a bracket, so it's different. Coefficient means multiplier. Okay? Now, so a is our coefficient. And so therefore, it has to be multiplied times how many of the things inside?
All of them.
Yeah, everything inside. Oh, come on, you. Everything inside. Every term. So how many terms do I have inside this bracket?
2.
Right, I have a b,
No, 2.
and I have a positive and a plus c, right? So there are 2 terms. So how many times do I have to multiply with the a?
2.
2 times. This is called the distributive property. You might have heard of it before, but if you haven't, you're going to take the a times the b, but you also have to take the a times the positive c. And do you see that sign in front of that c? It has to be part of that term. You can't forget that sign. So when you're multiplying, remember, we always say our sign first and make sure that you're bringing the sign with you. So let's look at an example of this. Now, okay. All right. So say we have, for example, and we're just going to do an easy one first, 3 times x minus 5. Okay? So I have a bracket. Where do I look first for any bracket? Just go ahead and sing out. Inside the bracket. But inside the bracket, I have an x minus 5. Can I subtract a 5 from an x?
No.
No, because that's an x term and that's a constant term. I can only subtract x's from other what? X's. And constants from other constants. You can't subtract an x from a 5. Good job. Okay? So I can't do anything inside. Do you see an exponent on this bracket?
No.
Nope.
It's a 1.
So it's a 1, so it's not going to do anything. And then we need to look for a coefficient. Is there a coefficient here?
Yeah.
Yes. What is the coefficient or multiplier? It's that 3. And that 3 has to be taken times how many of the things inside?
All of them.
Everything. Right? Okay? So what is the first term inside the bracket?
X.
Plain old x. So I have to take the 3 times that x. Well, what do I get if I multiply 3 times an x?
3x.
Just 3x, exactly. Right? Now, but I also have to multiply the 3 times the other term. What is the other term? And make me proud here. Think about that part. Minus 5 and negative 5. Good. Remember, there's a sign. So the 3 is a positive, right? Because it doesn't have a sign. So what's a positive times a negative going to make?
Positive.
Negative, right? When you're multiplying, if the signs are different, you get a negative. And then what's 3 times 5 going to make?
Minus 15.
So 15. Do the sign first, and then you won't have to worry about it later, right? And there is my completed answer. Can I now combine 3x and 15?
No.
Nope, because they're still not like terms. If they're not like terms up there, then they're not going to be like terms later. Yes?
It's an expression, not an equation.
Exactly. Why is it an expression and not an equation?
You can't solve.
You can't solve it because it doesn't have an equal symbol. Exactly. Okay? Let's do another one. And then I'm going to give you a couple to do because this is all we're doing today. But I need you to really understand what's happening, guys. Okay? All right, here we go. So say we have 5 times 3 minus 2x. Never changes. The rule is always the same, which is why you have to know the rule and not just the example, right? The example helps you visualize the rule, but it's the rule. All right, we have a bracket. Where do we look first? Inside, right? Well, inside the bracket, I have 3 minus 2x. Can I take a 3 and subtract 2x from it?
No.
Because they are not what?
Like terms.
Like terms. Excellent. Then you look to see if you have an exponent. Do I have one?
No.
No, which means it's an exponent of 1, but who cares? Because that doesn't do anything, does it? And then last, I look for the, what's it called? Coefficient, which is just a fancy word for a multiplier.
5.
What is my multiplier here?
5.
5. So that means take the 5 and multiply it times how many of the things inside?
All of them.
Both of them, everything inside. And in this case, I have 2. So starting in order, I'm going to take 5 times what?
3.
Which is 15.
And then 5 times minus 2x.
Yeah, done with that. Now I need to take the 5 times the next term, which is, again, what's the next term, guys?
Minus 2x.
Minus 2x. Good. And when you're doing that, because it's a term, we take it in pieces. First, we determine the sign. So the sign of the 5 is positive. So positive times a negative is a?
Negative.
Then we do the coefficient, the number parts. 5 times 2 is? 10. We're not multiplying with an x, so will the x change?
No.
No, it just comes straight down. There you go. Okay. Now, super easy, because you're just multiplying just like you always have, right? All right. Let's look at one that has some more stuff in it to see if you remember. Okay.
Excuse me.
Yes.
The last answer was 5 minus 10x. Is it
Yes.
possible to just do 5x because 5 minus 10?
No, it's 15 minus 10x's, but can you do? But if it's 15 minus, are they like terms? No, so you can't combine them. Okay, let's kick it up a notch. Here we go. Let's make it even more fun.
7, 8.
There we go. Let's make that a negative 3. So first thing you look, where you look, if we have a bracket, where do we look first? Inside. Do I have anything I can do inside this bracket?
No.
What color you want?
Pink.
Pink? Okay. So, nothing you can do inside, is there? Okay? What do you look for next?
The exponents.
Exponent, but is there one?
No.
It's really more lilac than pink, isn't it? All right. Then the last thing you look for is the coefficient or multiplier. What is the coefficient here?
Minus 3.
Minus 3x. Excellent. See how easy it is, but you have to pay attention. So, that means take everything inside and multiply it by negative 3x, or minus 3x. So the first term inside is this positive 4x. So I've got to multiply those two together, starting with the sign. So it's a negative times a positive, which makes a negative. Then you're going to multiply the numbers. 3 times 4 is 12. Then you're going to keep the base, right? So it's an x. And since we're multiplying an x times an x.
Is x. XX.
12x.
What? What?
Whenever you're multiplying, you add the exponents. What are the exponents now?
1.
So what's 1 plus 1 going to make?
2.
So x
Plus
squared,
9x.
right? Hold on a minute. We're not there yet because y'all are looking at me like I'm crazy. If you take an x times an x, that's the same as x to the first times x to the first, which is x to the second power. Yeah. Okay, don't forget what we've already learned. Now we're done with the 4x. Now what's the next term?
3y.
Close.
Minus 3y.
Negative 3y. There you go. Don't forget your signs. So I'm going to take the negative 3x times the negative 3y, starting with the sign. So negative times a negative is a
Negative.
positive. So signs are the same, then the answer is a positive when you're multiplying. Go back and look at your sign rules. Then 3 times 3 is 9.
xy.
And x times a y is
9xy.
xy.
Yes.
Okay? So there's your completed answer. So watch those signs. Now that I've got it all multiplied out together, can I combine the negative 12x squareds and positive 9xy's?
No.
Absolutely not. Okay. Pay attention here. 7x times x plus 2 plus 15x.
Woo, that got complicated.
Oh, no, not at all. Not at all. Okay, so
More than it was
here we go. It's got more stuff. Order of operations tells us that I have to start by simplifying the brackets. Do I have a bracket?
Yes.
Okay. Where does the bracket begin?
Inside. No.
Well,
7x.
with the 7x. Yeah, we're just, not the steps for it. Sorry, that's my problem. Where the bracket actually begins with the 7x.
So
And
why
it
don't you just
now,
write it?
does the bracket continue all the way to the end here?
No.
No. Where does it go?
The end of the bracket.
That's the bracket part. Good. Yes.
If the bracket starts at 7x and want me to just write it there.
Well, because that's the coefficient of the bracket. If you put the 7x inside, would it be the multiplier anymore?
No.
Mm-mm. It would just be combining inside. Right? Okay. Good question, though. So we've got to take care of this part first. Now, here's what I'm going to tell you. Part of the reason I don't like Education Perfect, I like it because it gives you consistent questions and we can work things together. The thing I don't like about it is it doesn't encourage you to write stuff down. So I need you to get used to writing things down. So we're not dealing with the positive 15x yet, so just bring it down to the next line. Don't leave it up there because you'll be concentrating on the bracket and you'll forget it. Okay? All right? So, now let's start with the bracket. Where do I look first?
The inside.
Inside, okay? So, inside the bracket I have x plus 2. Can I add an x and a 2? No. Is there an exponent on the bracket?
No.
Is there a coefficient or a multiplier?
Yes.
Yes. So the coefficient is positive 7x, so I have to take it times everything inside. So starting with the first term, positive times a positive is a?
Negative.
7 times, what number's in front of the x if there isn't one?
Positive.
Yeah, but what number's in front of the x if there isn't one? A 1. So 7 times 1 just stays what?
7.
7. And x times x is?
X.
X to the second power.
X to the second power, exactly. Remember, it's x to the first times x to the first, so x to the second. Now, we're done with the first term. Let's multiply with the second term. Okay? So, again, signs first. So positive times another positive is a?
Positive.
Positive. 7 times 2 is?
14.
14. Woo, guys. All right. And then, be careful here. X times nothing just stays X. There you go. Now, I got off on my line a little bit, but you see that that's after we multiply out the bracket. Now, think about it. You go into the store and you spend the money you have. Do they give you the items you bought and the money back?
No.
No. You use the money, it's gone. Once you've completed all 3 of those pieces of the bracket is gone. Don't rewrite it. Okay? Now, ready? Look up here, guys. Am I done with this problem?
No.
Why not? Go ahead, she was so enthusiastic.
You can't use those 2 numbers.
Right? Well, think about it. What is it?
If they're all like terms.
Exactly. There you go. If you look up here at these, you'll see that these 2 are like terms. And it's not simplified until we've finished. Now, is the x squared also a like term?
No.
Why not?
It will be, right?
Nope. Why is it not a like term? It's got a power of 2. There you go. Be careful. So 7x squared won't change, but these 2 are like terms, so I can combine them, right? Add them.
Yes.
What do I get when I take...
29.
Well, what kind of 29?
29x. I got it for you. 29x.
But also what?
Plus.
So plus 29...
X.
Now, are those like terms?
No.
No, because the exponents are different. They're never going to be like terms.
Yeah.
Okay?